ready?
Hello, people.
Say it a little louder.
Hello, people.
I swear, in every video you can hear Ben.
Probably.
And Edward.
But you can't hear me.
Well, now they can.
All right, those people that like to be heard. Ben, what's the answer to number 12?
I can't read it.
That is not the answer.
Okay.
You think?
Yeah.
Or does somebody else think that, and they quietly said it to you, so you can say it out loud? That's right. Edward right now knows he's next, and he's trying to get the next two answers. All right, so it was K. I'm not sure who's sitting around you got that right, but good job to them.
We had that one
What?
yesterday.
All right.
Also.
Number 13 is, that was on yesterday's warm-up?
Yes.
Yeah,
There's
there's 12
profanity
words.
on my
That's why I was just like,
All right, so 13 is B, and 14 is H. All right, there are 9 total hours, 4 of them are core, so you'd have to multiply 9 by 40 to get 360, so it's 160. 4 times 40.
how you put in the numbers 11 instead of 1, 2, 3?
12, 13, 14.
Yeah.
All right. I would like to see your homework.
Do you know where in Africa hippos reside?
East Africa.
Eastern, middle, western, or north?
I would say Eastern and Middle.
All of the
You know what the Native Americans are? That's the...
What I talked about on
Hey, Miss Lily, you can read about it.
my phone and stuff. I talked about.
I'm gonna keep that right
Why?
there.
It's not the last one then.
Because I'm obviously the skinhead.
I couldn't think of
It's
a word.
hard, Miss Lily.
Kind of good.
The Chuck
They're
Jumping.
good at it.
I tried.
I feel bad for Johnny.
So,
Yes.
Go back.
Johnny,
Come on.
I paid everyone this.
That's literally a lie.
She did with Mr.
What? Sue does not have a hippo.
She drew her.
What do you mean? I don't kill people.
We're drawing the detail now.
Leave a
so hopefully
gold
when it
line
doesn't
camera.
I'm sorry. Oh, it's so good.
There's a Guatemalan.
That's not.
Yeah, that's not necessarily.
I had one somebody on my
That's exactly what they're doing.
So it's the one on the corner.
All right.
No credit.
Okay. There are a couple of you that didn't copy the key on number 3. Exactly.
What?
All right. Let's talk about number 1. 1 and 2 were the ones we're used to. We have a buoy that's floating up and down in the water. All right, it's 3 feet from the lowest to the highest, so this is fairly calm water here. The period is 8 seconds, so we can solve for B. You may have written it like this. You may have used Y.
I did.
Whoops.
Yeah, what kind of code is this?
Okay.
Is it okay
to
use
use
X instead of T?
1.3 is the one you get if you use I remember.
Okay, so it repeats in 8 seconds. So it would look like this. We could write an equation really starting from anywhere. If you start from here, it's sine, and because it goes low and then middle and then high, it's going to be negated. It's a reflection. If you started right here, you could do a negated cosine. If you started here, you could do a positive sign, but these would be minus whatever. If you started here, because we use cosine a lot, and you went to where you could use cosine, it would look like this. Okay? Yes?
Wait, doesn't it say it starts at the highest? Even though, like, I know the equation is different.
That's what I thought, but in part A, it says on its way down.
Yeah.
Yeah,
It's negative.
it says on its way down.
Yeah, from the.
So it starts at equilibrium on its way down.
It starts at
So because of that wording, this is really what we would want to
That's a zero. Yeah, I could.
Read the question.
go with.
That's why we're
I just saw it
Down
went from
from
its
like-
highest point to its
It's
lowest.
equilibrium.
Read the question.
She was talking about the spread.
Yeah, it does say.
Easy square.
Like,
All right. Any other questions?
Yes.
Okay, this one was kind of easy. Because if you just think about it, if I just went 10, 12, wouldn't I be back down and then back at, there you go. And you didn't even have to do it algebraically because we can see it on the graph.
Number 3.
I'm not that smart.
Okay, what else? Anything else? Yes, ma'am.
I set it up where it didn't, I set it up where it didn't go underwater because I thought it was, like if the water was moving it up and down, but it didn't actually go underwater, so it didn't go like to negative 1.
It's not, what this is where like it goes normal, goes up on a wave, then comes down.
I just called the, where it was, and I called the trough 0.
Okay. So you did everything from here and this was 0. Okay.
Would that still be okay?
It can be if that's how you labeled it on your graph. Okay. This one was easy until you got to C.
Yeah, I'm kidding.
All right.
Johnny, you caught the big.
So it was the slinky,
No way.
5 feet. Now, this says how far will the toy have traveled after 200 seconds. If you plug in 200, you get 5. What does that tell you?
That's
That's
not
fine.
fine.
That tells you the height at that time. It doesn't tell you how far it's traveled. Do you see the difference? Okay. So how many cycles would it complete?
50.
50.
So 20 times.
Mm-hmm. That's 20 times the 50.
Yeah, 20 times.
50?
Yeah.
50?
50.
55.
Wait,
Not 50.
shouldn't it be inches instead of feet?
Yes.
Oh.
It should be inches. You are correct.
Hey,
Oh, yeah. 50.
Thank you. All right. So the last one. All right. Mr. Campbell must have taken art in college because I'm about to draw my version of the same problem on the board.
So that cactus in the shadow is like
Oh.
Okay.
It's like.
So,
I just like
That should be art.
do some little scribbles.
that would have been my cactus.
That was
that was
There we go.
That was
And I probably would have done something like this. Cactus. All right. And then, for me, I kind of think of the sun rising in the east,
Setting in the west.
setting in the west. So my sun would come up from over here, right? And it would travel whee, until it sets over here.
The sun doesn't actually, we're the ones that do.
Okay? So, if I have to convert this idea to a coordinate grid, where it rises would be in a positive direction, where it sets would be in a negative direction, right? Okay, so as the sun rises, what we're going to do is we're going to notice it's going to, that's not proportional. The cactus wouldn't be that much bigger than the sun. Okay? All right, so we'll shrink the cactus down to something closer to still not proportional. But anyway, when the sun is lowest, we're going to have that longest shadow. And according to the wording here, it's as far as the eye can see. Okay? Now, if that shadow goes this direction, that's kind of towards negative infinity, isn't it? So, at this time zero actually represents what time on the clock?
6
6 a.m.
a.m.
6 a.m.
That's what time.
So that would be time zero. And it says 12 hours later the sun sets. So that's 6 p.m. Must be like December when we don't have much daylight. Okay? So it's coming up at 6 a.m. It's setting at 6 p.m. So where would it be directly above the cactus? At noon. All right. So this is high noon. All right. So if this is time zero, and this is 12 hours later, that would be time 12. Directly above the cactus would be what time? 6. Okay. All right. So let's just let the sun travel. Here's the sun. Okay. So if I put it halfway here, what kind of angle does it make? 45. It doesn't go to the other sun. Sorry. It makes a 45-degree angle. Totally not drawn to scale.
The cactus.
Okay? So this, if this is 45, it creates a 45, 45, 90 right triangle. So the height of the cactus would be equivalent to the height right there, doesn't it? Okay, but when it's not 45, which is nice, that gives me my 45, 45, 90 right triangle, I'm still trying to see as this changes, what happens to this length. Well, this one I know. This one is 30. This one I don't know. Which trig function would involve the angle that gives us the opposite over the adjacent? Tangent. And that's where the tangent came from here. Do we get it? All right.
Yes.
Now, Mr. Campbell is artistic. And he can draw like a almost real-looking cactus with a very good shadow. I draw sticks.
I draw sticks.
Thank you. Sticks work. They form triangles. Makes pretty triangles. All right. So here is where we're thinking through what we just drew on the board. Same process. So at 0 hours, we have 0 degrees, and this shadow isn't really, but we'll call it negative infinity. Okay? At 9 a.m. At 9 a.m. Why do we call this negative 30?
Because it's the other side.
Because it's over here. If the sun is over here, it's causing the shadow on this side. The negative is not part of the length of the shadow, it's the direction of the shadow. That's what the negative means. So the negative tells us the shadow is over here. Then at noon, there is no shadow. At 3 p.m., the shadow is now over here because the sun is over here. Okay? So now it's a positive 30. And then at 12, the shadow is completely this way. At 6 p.m., 12 hours later, the shadow is completely over
And
here.
so, like, after that, then that's when the tangent would break. Like, the tangent line would break because there was something. Okay, well, yeah.
Okay.
So that's why we changed it.
Yeah.
Alright, well, I got it.
I get it now.
And we would have this full cycle, and then this would be weird.
How weird.
Because what would happen for the next 12 hours?
It would be
Nighttime.
It would be dark,
That's why I did a sinus hole.
and then we wouldn't have anything. There'd be no shadow.
Oh, that's the point of doing this.
So it would be like part of a tangential curve, and then nothing, so a segment, and then on the other side of the next asymptote, we'd have another tangent curve. Okay, all right, but anyway, we're just describing the words here, and it didn't say 24 hours, it was the first 12. All right, so we know where tangent comes from. Where's the 30 come from?
The height of the stretch that you have.
The vertical stretch. It calls a vertical stretch of 30 feet. The height of the cactus is 30 feet. That's where the 30 comes from. All right? Now, because my period is 12 hours, I solve for b. Because it's tangent, instead of 2 pi over b, it is just pi over b. And we saw when we get b is pi over 12. So you could write it in this form, or you could write it in this form. In this form, we can see that shift of 6. In this form, that's just distributed. All right. That one was a thinker. Or it was a copier, depending on what you were willing to do. All right. And we've kind of already interpreted all the parts. The vertical stretch was 30, it's the height of the cactus. The 3 hours represents 9 a.m. and the 9 hours represents a 3 p.m. That's the length of the shadow. And when they'd be equivalent, we solve for C by distributing. All right. Any other questions about our cool little tangent problem? Yes, ma'am.
So when it says that we said that it went on for infinity, we were just like pretending that it went on for infinity.
Infinity's not a reality.
Right.
Really? I never stumped on that.
Yeah.
Yeah, but I was trying to explain that to you.
Yeah, infinity's not a reality. And then we've got the curvature of the Earth,
Yeah.
which would play with that.
I love that.
And so it's a tangential idea. But you're right, it doesn't go to infinity. All right. Any other questions? I like that because that means you were thinking a lot. Oh, I didn't mean to do that.
I don't give myself a mind or anything, but
Is this your favorite kind of math?
Oh no.
What's your favorite?
I think I just accidentally shut that without saving it. Okay. It is what it is. All right. So today we're going to practice some more